Hi everyone, my name is Amitesh, and in this video we're going to do a super fun and quick introduction to what are the basic values of sine and cosine. And I've taught this kind of material a lot at Princeton University, and this is going to be a quick overview of that so that you have a complete mastery of what is sine 30, sine 60, sine 45, cosine 30, cosine 60, cosine 45. So let's just dive right into it and start off by talking about these. I don't even need to know what sine and cosine are. I'm going to kind of review it while we talk about it because the review is pretty accessible. So what we're going to do is we take a right triangle and we have an angle of theta here, okay, and we make the hypotenuse 1. Okay, so side length of the hypotenuse is 1, and once you fix the angle and the hypotenuse, of course, as the angle changes, your triangle is going to change and your side lengths of your adjacent side to your angle and your opposite side to your angle are also going to change. So we need to figure out some values on sine and cosine according to what the angle of theta is, where cosine theta is going to be the adjacent side length and sine theta is going to be the opposite side length of this right triangle. So it's going to depend on theta. Generally it's a hard problem. If you give me a theta, it's very hard to figure out what these cosine theta and sine theta should be, but for some angles it's pretty nice. So let's dive into what are some examples of such angles. So the first example, so I'm going to talk about, is the angle of 45 degrees. Okay, so 45 degrees, what happens, so we're going to draw a right triangle and we're going to put an angle of 45 degrees here and 90 degrees here. Now the sum of the angles in a triangle add up to 180 degrees. So if this angle is 45 degrees and this is 90, the other angle has to be also 45 degrees. Just check that, check that you can see that because the angles have to add up to 180. So we've got two equal angles and 90 degrees here. Now it is a geometry fact that if the angles here are the same, this is going to be 90, then these side lengths here are going to be both the same. So whatever these side lengths are, we call them x, they're both going to be equal to each other. So this is intuitively also true because 45 degrees is the perfect half of 90 degrees. So this is when the opposite side and the adjacent side match up perfectly. If the angle was less than 45 degrees, the adjacent side would get bigger and the opposite side would get smaller because this point of the triangle would kind of go down. And if the angle was greater than 45 degrees, the point would go this way, and so the vertical side would be bigger and the adjacent side would be smaller. 45 degrees is when it's just right. And here what we can do is we know, okay, we're defining a right triangle with hypotenuse 1, and we know that x is going to be the value of cosine 45 or sine 45. That's how we've defined cosine and sine. The adjacent length is going to be cosine 45, and also the opposite side or the opposite length is going to be sine 45. So they're both going to equal to the same thing. Okay, so that's really cool. Cosine 45 is equal to sine 45. And now we're going to do a famous theorem, which is the Pythagorean Theorem, that tells us how the side lengths of a right triangle relate to each other. And again, I've done videos on this. Check them out. Links in the description. We've got playlists on different kinds of content. Please check them out. I've done a quick video on it. So what is the Pythagorean Theorem going to tell us? It's going to tell us that 1 squared is equal to x squared plus x squared. So the sum of the squares of the adjacent side and the opposite side is going to be the square of the hypotenuse. So here we have x squared plus x squared. Only add something to itself, you double it, so you're going to get 2x squared. So therefore, if you want to isolate the x, you get 1 is equal to 2x squared, which implies that 1/2, if you divide both sides by 2, is x squared. And now we are almost at the step of finding x. We know that therefore, if you take the square roots, x is going to equal to the square root of 1/2, which is also the square root of 1 divided by the square root of 2, which is going to be 1 over the square root of 2. Okay, so that's what x is going to be. It's 1 over the square root of 2. The square root of 2 is 1.414, etc. So 1 over that is something between 0 and 1, which is generally typical when you have cosine theta and sine theta for an angle between 0 and 90, that because the hypotenuse is going to be the longest side, these two sides are going to be between 0 and 1 in length. Okay, so that's consistent, and we have 1 over root 2. Sine 45 is equal to 1 over root 2 is equal to cosine 45, and sometimes people write 1 over root 2 is equal to root 2 over 2. Sometimes you'll see that in tables because root 2 over 2, because 2 is equal to root 2 times root 2, right? If you multiply root 2 with itself, you get 2. So therefore, you can cancel this off and also say this is 1 over root 2. So sometimes people will write it as root 2 over 2, just to kind of show you it's the same thing. Okay, so that's sine 45 and cosine 45. Now let's dive into sine 30 and cosine 60 and cosine 30 and sine 60. Now what we can say is that if you have 60 degrees, then you're going to draw a triangle. So it's going to be something like this. And here your angle is going to be 60 degrees. Okay, and here you're going to have 90 degrees. And of course, what's the third angle going to be? Because they add up to 180, it's going to be 30 degrees. Okay, so here you have 30 degrees, and here your hypotenuse is 1, and you want to figure out what the side lengths are. So we know that by definition, you know, what is cosine 60 and sine 60? Well, cosine 60 is going to be the length of this adjacent side, so it's cosine 60, and here you've got sine 60. And now we're going to do a really beautiful trick. We're going to take this triangle and we're going to repeat it on the right. We're going to take its mirror reflection and we're going to draw a big triangle, which is comprised of these two little triangles. So what that's going to be is we're going to draw this like this, and here we're going to have, this is going to be also 60 degrees, this is also going to be 30 degrees, because we've literally flipped the triangle over. Okay, so we flip the triangle over, we get those angles, and now notice something really beautiful here is this is going to be an equilateral triangle, because all the angles, this big angle here is going to be 30 plus 30, which is 60, and these two angles are also going to be 60. So we're actually going to get this nice little equilateral triangle, which is going to have 60 degrees everywhere, right? 60 degrees, 60 degrees. What that tells us is that here the hypotenuse is 1 and here also it's 1, right? You can see that in two ways. One is because you flip the triangle. The other is because it's an equilateral triangle, so all side lengths have to be the same because all angles are the same and equal to 60 degrees. So here we know that this total length is going to be equal to 1, but of course you see that when you flip the triangle, this half length is cosine 60, the other half length is also going to be cosine 60. So we can sort of write it here, so I'm going to sort of erase this here. This is also going to be cosine 60, and so what we know is that because 2 times cosine 60 is going to be 1, we can solve an equation. 2 times cosine 60 is equal to 1, so therefore cosine 60 is going to equal to 1/2. Okay, so that's going to be the answer for cosine 60. And now you can figure out also what sine 60 is going to be. In this triangle, sine 60 is going to be this vertical edge, it's going to be sine 60. And we know that we've got cosine 60, which is going to be 1/2. We've now got a right triangle here, and we can use the Pythagorean theorem to figure out the missing value. But I'm just going to draw the triangle. So here we have sine 60, we have 1/2, and we have 1. So the Pythagorean theorem tells us that the sum of the squares of the two sides is equal to the square of the hypotenuse. So therefore, 1 squared, which is the square of the hypotenuse, is going to be 1/2 squared, which is cosine 60 squared plus sine 60 squared. And therefore, we know that 1 minus 1/2 squared is 1/4. If you take half of a half, you get a 1/4. So you get 1 minus 1/4 is equal to sine of 60 squared. Sine 60 squared is 1 minus 1/4, so we can figure it out together. 1 minus 1/4 is 3/4, so 3/4 is equal to sine 60 squared. And therefore, if you take the square roots, you're going to get that sine 60 is going to equal to the square root of 3 over 4, which is going to be the square root of 3 over the square root of 4, which is 2. Okay, square root of 4 is 2, so we get square root 3 over 2, that is sine 60. So this is the famous root 3 over 2 value for sine 60. And that tells us what cosine 60 and sine 60 are. That's what's beautiful is when you draw the triangle here that we've sort of seen, we have a right triangle, you know that this is going to be, 1/2, and this is going to be equal to root 3 over 2. And this is going to be 60 degrees, so this is root 3 over 2. We've sort of figured that out. But now, because you know the last angle is 30 degrees, you can flip the triangle, you can rotate the triangle, okay? So if you rotate the triangle, you're going to get this triangle where I'm just going to rotate it 90 degrees clockwise, okay? So 90 degrees clockwise, I rotate it, then what I'm going to get when I do that is I'm going to get this length is 1/2, and this length is going to be root 3 over 2. And now this angle is going to be 30, and this angle is going to be 60. But now we have a right triangle where the angle is 30, and we know that the adjacent side and the opposite side are going to be the values of cosine and sine of 30 now. Okay, so that's kind of a cool trick that allows us to go from one value we knew to another value, and now we can conclude, and these are the basic fundamental values of sine and cosine that are really helpful to know. And I've done them in degrees rather than radians, but I'll have a video on radians, and once it's uploaded, you can check it out, and links will always be down below. Scour my channel, see the playlists on trigonometry, etc. So here what we can do is we can say cosine 60, but for your convenience, I'll keep relevant videos, links in the description always. So cosine 60 is going to equal to a half. Okay, and similarly, sine of 60 is going to equal to root 3 over 2, which is going to equal to cosine of 60. Okay, and one way of doing it, I'm going to just give you a cool table that you can screenshot, and the table is going to have sine and cosine and the degrees. So I'm going to put degree, and then we're going to put cosine or sine and cosine. And so here we can sort of draw this table. So I'm going to do these degrees 0, 30, 45, 60, and 90. Okay, and so I want you to just see if you can fill these in, okay, from memory. It's very helpful to memorize these. I would strongly recommend it. Generally, I don't recommend memorizing stuff in math. Of course, you should always understand things before you memorize, but once you've understood it, it really helps, because in exams, tests, homework, assignments, in high school and college, and just day-to-day thinking about math with trig, these values come up a lot, so it just helps to just know what they are. But here you have sine of 0 is 0, cosine of 0 is 1, then you have 1/2, root 3 over 2, then you're going to have a 1 over root 2, and then 1 over root 2, and then you're going to have root 3 over 2, and then you're going to have 1/2, and then you're going to have 1 and 0. And the way I like to remember, sometimes when I first learned this way back, when I was in school, I had difficulty sometimes remembering which one is a half and which one is a root 3 over 2, when you go from 30 and 60 or sine and cosine. So one way of remembering it is just sine kind of steadily increases from 0 to 90. So 1/2 is less than root 3 over 2, because 1 is less than root 3. Root 3 is about 1.7 something. So you know that the root 3 over 2 has to be the 60, and the 1/2 has to be the 30. And then the 45 is kind of the most visual, I feel, because it's the Pythagorean Theorem directly applied to two side lengths that are the same. But it's kind of the odd one out. So it's something you can remember. It's 1 over root 2. Start at 0, end up at 1. And cosine is the opposite. So once you've got that down, you can remember these values. I hope you loved that video. My goal is to create free accessible math education worldwide so everyone can love and enjoy and benefit from math. And I've taught this material at Princeton University, but I want everyone to have access to it, no matter where you are or what high school, college you're going to or not going to, that you have the opportunity to learn and enjoy math, or everyone who's watching this video. And by liking and subscribing, you really help me achieve my goal to help as many people as possible. So it means a lot if you've watched this far. Thank you so much. It means a lot to me. And I hope I supported you similarly by this content. Please drop a comment down below. I'd love to hear your feedback, but I'm super excited to see you in the next video. And please look at my channel, check it out. Lots of playlists on all different kinds of concepts. I hope you all find it very helpful for you. So see you soon, and wish you all the best.